Okay, last lesson we learned or reviewed distributing. So to distribute, if I were to distribute this, I would take 4x times 2x and get 8x squared. Remember, those x's are both to the first power. 4x times 5 is plus 20x. Now today, what we're going to learn is to do the opposite. So when you distribute, you multiply things through. When you factor, today's lesson is on factoring polynomials. Factor means you're going to take things back out and you're going to divide them back out. So one of the first things you need to do is you need to figure out what's called the GCF, which is called the greatest common factor. Now in this one, we already have the greatest common factor because we're going to undo what we did before. So what we're going to do is we're going to pull a number back out, but what it is it's like dividing it back out. So in front, the opposite, we're going to look at this one, and we're going to pull back out the number called the GCF. It's the biggest possible number, the greatest possible number, greatest common factor. Biggest number we can pull out, because greatest means biggest. Common means it has to come out of both of them. And then factor means we're going to pull it back out, we're going to divide it back out. Well, in doing that, what you need to realize is I'm dividing this by 4x in that sense. If I were to divide that by 4x, I have to think what would be inside here if I were to multiply it. Inside here, what I would have is a 2, because 4 times 2 would get me 8. Inside here, I would have an x, because x times x would get me an x squared. You have to think backwards with what we did in the last lesson. Okay? Now, the next part, 4 times what would get me 20? Well, 4 times 5 would get me 20. And then there's an x. If I were to multiply this right now, that would get me the 20x in here. So I'm going to close the parentheses. So the final answer here is going to be the same as what we started with over there. So the difference now, we will not be starting and multiplying through. We have to think what will go into both of those. What will go into the terms? Again, this is what we call a binomial. It has 2 terms. The first one we have on here is 3x minus 12. And what can go into 3x and what can go into 12? The biggest number, or the greatest common factor that will go into both, is 3. So we're going to pull out that 3. And now we have to think through, what would I have multiplied 3 by to get 3x? Any ideas? 1 what? 1x. Because 3 times x would get me 3x. Okay? So now, if I were to multiply that, would I have 3x? What would I have to put here to get negative 12? Negative 4. So if you were to multiply this, you would get 3x minus 12. You'd get back to this. So this is what we call the factored form. We have factored it. We've taken the greatest number out that we could out of both of them. Okay? Now this next one. Watch, because I'm going to do this one wrong. So please don't write this one down. Some people might say I'm going to take out 2. Well, 2 times 2x would be 4x. That's correct. And 2 times 18 would be 36. That has been factored, but it hasn't been factored with the greatest number, because both of these numbers in here could still be divided by 2. So understand, one of the things we always want to do is we want to take out the biggest or the greatest common factor. It's called the GCF. We want to take out the greatest number possible that's common as a factor. 4 is bigger than 2. So if I divide by 4, in here, I would get x. If I divide 36 by 4, I would get 9. Now, if I were to multiply that, I would have 4x plus 36, because 4 times 9 is 36. All right, this next one. Now, when there are negatives involved, it's okay if you take out the negative. It's okay if you don't. This one, I'm going to simply, whoops, not 3. I'm going to take out 7. 3, I can't divide 7 by 3. But I can divide both of these. I can divide them both by 7. So I'm going to factor out a 7. Now, 7 times what is 21? Negative 3x. That's good. And you got the negative in there. 7 times what is 7? 1. So a lot of times students will forget the plus 1. You got to remember that that gets multiplied by both. And 7 times that, negative 21x. 7 times that is plus 7. Okay, so can you look at this next one? Can you figure out a number? Can you try that? I'm going to give you about 15 seconds to try. See if you can pull out a number that would divide out of both, the greatest common factor, and figure out this one in reverse. What number did you put in front? 4, because 4 will, you can divide them both by 4. Now 4 times 1 is 4, minus what? Negative 5x. Very good. All right, now this next one, since they're both negative, I am going to take out a negative. Again, with the negative, it wouldn't matter if you didn't take the negative out, but since they're both negative, I'm going to pull out a negative. Now, negative 7 times 6 would be negative 42, and I would need a y. That would make negative 42y. The next number is plus 1, because negative 7 times 1 is negative 7. Shifting gears a little bit more with part F. This one, a little more complicated, because now it's dealing with the variable. But for both of these, I could divide out a y, just one. I can't divide out y squared, because the second one only has a y. Now remember, that's y to the first that we're pulling out. So what that will do, this one's y to the first, that times that will get us y squared, because we add the exponents. The next one is plus 17, and when I distribute the y, it'll become 17y. Can you look at the next one? Can you try that one? Compare it to this one. I'm going to give you about 10 seconds to try this one is all. We pull out an x. What do we get inside? Plus 12. Good. All right. Now this next one. Now it's got numbers on both. There's no numbers that will go into 3 and 7, but I still can pull out an x from both. X times 3 would be 3x. X times 7x would be 7x squared. Okay. This one, I'm going to write it a little lower. X can come out of both. That'll take that one down 1, 7x squared. That will take that one down an x. All right, now the next one is a little bit different. You can never take out more than what one of them has, but one of them has x squared, so it has two x's being multiplied. Does the other one, since it has four x's, does it have at least two? So we can take out an x squared. It will bring this down to 8x squared. When you multiply those, you'll have 8x to the 4. This one, minus 27. If you multiply that, you would get minus 27x squared. Is that making sense? Now more with the numbers. Okay, kind of the first ones we dealt with numbers on that last page. Then the second ones we dealt with variables. This one, we got numbers and variables. 3x squared. So 3x squared, to get 6, I'd have to multiply by negative 2. Now, if I multiply that, it's going to be negative 6x squared because the x squared's already there. So inside, there are no more x's. The next one, 3 times 1 would work, but I need x squared because 2 on the outside, 2 on the inside makes the total of 4. If I multiply those, I get 3x to the 4. Make sense? Okay. This one, I'm going to bring out a 2x. 2x times negative 4x would get me negative 8x squared. Plus 1, 2x times 1. A lot of times students forget that one. I'm going to give you 15 seconds to try the next one. See if you can figure out there is a number that will go into both 6 and 15. And then you can bring out at least one of the letters. So try that one. Go. What number will come out? What can you divide them both by? What? 3. And then there's a y. 3 times 2y. 3y times 2y would get 6, y squared. 3 times negative 5 would get negative 15. And then the 1y on the outside, there'd still be a y. So if you were to multiply it through, distribute it through, you'd get back to that, right? All right, the next one. 3w to the third. Negative 7w plus 1. A lot of times students will forget the 1. All right, let's try this one, see if you can do it. So you bring out a 4, you bring out a q. When you multiply by q3, that'll be 4q to the 4th. When you multiply 4q times 3, you get 12q. Should work. All right, now a little more complicated. Now we got 3 terms. So here, we have to find a number that'll go into all 3. So for instance, I could divide them all by 2. Okay, but 2 is not going to be the greatest common factor. Now, there is a way that we can use a calculator to find the greatest common factor. I'm not sure if I remember how, but if you have one of our calculators, menu number, I don't think it's going to be greatest common divisor. What were the numbers in front? I don't think that's it. 24, 18, 30. No. Should say greatest common factor. Okay, it doesn't do greatest common factor on here. Either that or I've forgotten how. So there's a mathematical way to figure it out, but it's kind of complex. The mathematical way is you break down these numbers as much as you can. 24 is 2 times 2 times 2 times 3. 18 is 3 times 6. 2 times 3 is 3 times 2 times 3. 30, 5 times 6. 30 is 5 times 2 times 3. Then you look for anything they have in common. For instance, they all have a 2. They all have a 3. You have to be able to circle it in all of them. Now, what's 2 times 3? 6. So 6 is what we would call the greatest common factor. Now you look at these, there's 3 x's here, 2 x's here, 1 x here. The most we can bring out is an x because the last one only has 1 x. So 6x is what we call the greatest common factor. 6 times 4 x squared would get us 24x to the third. 6 times 3 with an x would get us 18x squared. Minus 5 would get us negative 30x. Now the next one's a little simpler. There's a 5 on the first one. Well, 5, since 5 is the smallest number, you can never take more than what one of them has. You can always look at the smallest number, see if it works. Will 5 go into 20? Will 5 go into 45? So 5, and then an n. This one only has one n. You cannot take more than one of them has. So we can take a 5 because that's the smallest coefficient, smallest number in front. We can take an n because that's the smallest number of variables. Now you have to figure out the inside. I'm going to let you try it. See if you can figure out the 3 numbers that should be inside. Negative n squared plus 4 minus 9n. Is that what you got? Notice they all came down, one n. Like the middle one doesn't have an n because the n moved to the outside. All right, the next one. Got to figure out what will happen in R here. 9 will go into 54. It will go into 18 as well. We have 1m in the last one, so I'm going to bring out 9m. So again, I'm going to let you try it, see if you can come up with the 3 numbers inside. You got about 15 seconds here. Go. Two m squared. You multiply that, you get 18m to the third. Plus m to the third. You multiply that, you get 9m to the fourth. Minus 6. All right, S. Try it all on your own. See if you can bring out a number that goes into both of those and as many variables as you can. You can't take out more than the smallest, but look what the smallest is in part S. I'll give you the greatest common factor in about 10 seconds. H squared. Is that what you came up with? 15 will go into all three. H squared, at least 2. Negative 1 plus 2h squared minus 3h. The last one on my board is cut off. See if I can find it on here. Where did I get what? Well, if you don't put the negative 1 there, then when you multiply this, how are you going to get the 15h squared? See, 15h times that gets you the negative 15h squared. So, got to be 3 terms. If you only have 2 terms inside, then you're only going to have 2. So, T, 12, y to the 4th, plus 6y, minus 18, y squared. 6 can come out with a y. 2y to the 3rd, plus what? 1 minus 6 times what's 18? 3 with a y. Okay, that's part T. All right, U. What can go into 49 and 14? Anybody have any idea? 49 is what times what? 7 times 7. Will 7 go into 14? Let's bring out a 7. Now with the A's and B's, I can bring out an A because this one only has one A. The other one has 2. I can bring out one B because this one only has one B. So 7 times 7 is 49. And this one has an A because now if you multiply it, you'll have 49A squared and a B. 7 times 2 is 14. And I need one more B so that it gets the B up to a squared, but there'll already be an A because of the A on the outside. All right, B. 4 is the biggest we can bring out, and we can only bring out 1x. 4 times 4 is 16. with a y squared. If you multiply that, you will have 16, 1x, and 2 y's. 4 times 3 with an x will get us 12x squared. All right, let's have you try W. I'm going to give you 15 seconds to try part W. Three C D squared. Now, if you're not sure, how do we come up with that? First of all, 3 is the smallest number in front. It will go into 18. Why did I only bring out one C? Because the first one only has one C. You cannot bring out more than what one of them has. Why did I bring out 2 D's? Well, this one has 3 and this one has 2, so 2 is the smallest amount, and you always bring that out. It'll be the biggest number you can bring out of both of them. Now, this will give me negative D. I have to get the D up to D to the third. That'll make negative 3C D to the third. Plus 6C, and that's it. That'll get us up to 18 C squared D squared. Here, 12 is the smallest number. Will 12 go into 24? So we'll bring out a 12. This one has a C. This one has a D. That's the most we can bring out. 12 times 2 is 24. I need C3 and D1. That'll make it C4D squared. Plus what? 1. It's usually the thing a lot of students forget. When everything came out, you still need to multiply that through to end up having 2 terms. All right, the next one, last one. 5mn is going to come out. Negative 2m3n plus 1. So ends the lesson.